Hi, my name's Catherine Tigzot. Today I'll be talking about employee attrition, looking at trends, analysis, and predicting attrition. I'd like to start with job-specific trends. So looking at the mean monthly income of the employees, it's categorized by job role and their corresponding mean monthly income. We can see that sales representatives have the lowest mean monthly income, whereas managers and research directors have the two highest mean monthly incomes. Looking at job levels, I have a box plot to show the distribution of job levels by job roles. So we can see that sales reps, research scientists, lab techs, and HR roles have median job levels of 1, with a couple outliers, of course, but based on those box plots, it's safe to say that the majority of these employees in these roles probably have a job level of 1. We see that research directors and managers have a median job level of 4. Now, looking at the number of years at the company, I have a box plot here to show the distribution of the number of years at the company by job role. I want to point out the distribution of the sales representatives' number of years at the company is both smaller and less than all of the other roles. Of course, there are outliers, but generally that is an accurate statement. Research directors and managers have the two highest medians when it comes to number of years at the company. Moving on to attrition. So in this sample, there were 870 employees. There were 84% of the cases where there was no attrition, so the employees stayed, and 16% of cases of attrition. So 16% of these employees left. Looking at this by department, we can see that a little over half of these attrition cases were in the R&D department, then sales, and then a tiny percentage of HR. However, when we compare this to the entire sample, we see that sales has a disproportionately higher rate of attrition when compared to the percentage they make up in the entire sample. Looking at this by job role, we can see that sales executives, research scientists, and lab techs each all make up around 20% of the attrition cases. So total around 60%. But when we compare this to the proportion they make up of the entire sample, it isn't that alarming. However, we do see that sales representatives disproportionately make up a larger percentage of the attrition cases than they do in the entire sample. The percentage of attrition is almost 3 times more than the proportion they make up of the entire sample. On the other hand, we see research directors and manufacturing directors with proportionately much lower rates of attrition compared to their proportion of the entire sample. Moving on to the 3 factors contributing to turnover. The variables I will discuss and highlight are job level, job role, and environment satisfaction. The plots in the following slides will support this claim. So looking at job role and job level, I have the job roles on the x-axis, job levels on the y-axis. Attrition is denoted by color. Red is no attrition. Blue is yes attrition. So looking at sales representatives with a job level of 1, we see there's almost a 50-50 split of attrition cases, or maybe even more cases of attrition than non-attrition. That's just from visually looking at this. Now, looking at the variables, job level, environment satisfaction, and department, we have environment satisfaction on the y-axis, job level on the x-axis, department denoted by different shapes. Attrition is indicated by gray for no, red for yes. And we can see a lot of attrition cases in research and development and sales departments, not so much in HR, but remember, HR only makes up a small portion of the entire sample. We see a lot more red points where job level is lower, particularly where job level is 1. I want to point out here where environment satisfaction and job level both equal 1. Visually, it looks like there's almost a 50-50 mix of yes and no attrition cases. And again, we see a lot of triangles and squares there for R&D and sales. I want to show the linear regression of overlaid on these variables by attrition. So the red negative slope is for attrited cases. This gray slope is no. It's kind of hard to see, so I'll highlight here in yellow. We see a very, very slight positive slope here. Now, I would like to talk about predicting attrition and modeling that with KNN. First, I wanted to create and evaluate a model with a data set where I know what attrition is. You can see that I have a training and test set with a 70-30 split. I use the variables years in current role, years since last promotion, age, and job level. By applying this KNN model to the data set where attrition is unknown, I am able to predict the attrition of those employees in the data set. Before I show the results of that model applied to the unknown data set, I'd like to talk about evaluating the model. So you can see the confusion matrix at the top, that the model correctly classified 137 out of 230 of the non-attrition cases, and it correctly classified 25 out of 41 of the attrition cases. This gives us the sensitivity of around 62% and specificity of around 61%. Now to the results of this model. So in a sample where attrition is unknown, there are 300 cases, and the model predicted that there are 290 employees that will stay at the company, so no attrition, and it predicted that 10 of those employees will leave. So in percentages, that's around 97% of employees who will stay and 3% who will leave. That wraps up my presentation for today. Thank you so much for listening. Again, my name is Catherine Tixon. If you have any questions, please feel free to email me. My email is on the screen.